Hello, my name is Murali Koppula. This presentation is part of my final project for the cloud computing course at Harvard Extension School taught by Professor Zoran Georgievich. I have conducted the study to explore and demonstrate the techniques of client-side encryption of data stored in Amazon S3 service. Here, I will describe the S3 client-side encryption. Client-side encryption is part of the Amazon S3 security architecture. It is designed to protect the data at its various stages. Several techniques are used to provide a high level of protection to the data stored in S3. What is data protection in the context of Amazon S3? There are three phenomena that the data needs to be protected from. Amazon S3 is designed to protect the data from loss of data when the data is totally lost. Secondly, even when there is no actual loss of data, data still needs to be protected from various forms of corruption. Any such corruption of data can lead to a loss of integrity. Thirdly, data needs to be protected from unauthorized access. There are several techniques that S3 uses to protect data. S3 calculates checksums of data packets on the stored data to protect the data integrity. Versioning and replication of data protects from loss of data. Lost data can be restored or corrupted data can be repaired using versioned or redundant copy of data. Access management services provides protection against unauthorized access to data. When the application needs to access multiple resources, the user may need to authenticate each of the resources. When the number of resources are many, such authentication is not feasible or practical. Identity federation addresses the need to authenticate to multiple resources automatically without the need to sign on multiple number of times. Data encryption provides an additional layer of protection against unauthorized access to data by protecting the data even in the event of unauthorized access to the S3 service. Data is at rest when residing on S3. Data is in transit state when the data is downloaded from S3 or when the data is uploaded to the S3. Encryption of data, access policies, and data redundancy protect data at rest. Secure transmission protocols and client-side encryption protects data in transit. Checksums provide data integrity for data in its both states. There are two types of data encryption, server-side and client-side. In case of server-side encryption, S3 encrypts data before saving on the disk and decrypts the data when retrieving from S3. The data is not in encrypted form in transit. In client-side encryption, the data is encrypted by the client before uploading to S3. It is decrypted after retrieving from S3. This project describes and demonstrates the use of client-side encryption. Encryption involves the data to be encrypted, the plain text, the encryption algorithm, and the keys that are used in the encryption of the data. The unencrypted data is the plain text. The encrypted data is the ciphertext. The data encryption involves choosing the right encryption algorithm. It also involves the methods of protecting and managing the encryption keys. Decisions such as where the keys are stored and who manages the keys must be made. The storage and management of keys is called Key Management Infrastructure, KMI. Amazon offers a hardware-based solution for storing the keys called Cloud HSM. It also offers a key management service called Amazon KMS. Both these services are offered by Amazon at a price. Both these services can be used for both server-side encryption and client-side encryption. In this picture, we see the three models A, B, and C for encrypting data in S3. In model A, we can control the encryption method as well as the key storage and key management. In model B, we can control the encryption method and the key management, and AWS controls the key storage. In model C, AWS controls the encryption method as well as the key storage and key management. The client-side encryption fits the model A in this picture, where we can control the encryption method as well as the key storage and the key management. Client-side encryption can choose to generate and use its own master key or Amazon Key Management Service Managed Customer Master Key or CMK. The model B, Cloud HSM, is used to store the keys. The key management tools that are used in model A can also be used in model B. Model C is the case for server-side encryption. The subsequent slides describe and demonstrate the client-side encryption. In client-side encryption, objects are encrypted before uploading to S3. Thus, the data in transit is protected. Client uses its own choice of encryption algorithm. Client also has the option to store and manage its own keys. So, in client-side encryption, client controls both encryption and the key management infrastructure. There are several options available regarding the tools used to encrypt the data. The open source options are OpenSSL and Bouncy Castle. Amazon AWS includes an encryption client API called S3 Encryption Client. It is available in Java, Ruby, and .NET platforms. It provides both symmetric and asymmetric encryption. Amazon Encryption Client can be used both locally or on an EC2 instance. Figure 2 shows the two cases when the encryption client used locally and when encryption client on the EC2 instance. After the keys are generated locally, the keys are used by the encryption client. Notice that in either cases, the keys are still controlled by the client. So, in the case when the encryption client is on EC2 instance, the keys are transferred from the local system to the EC2 instance. In such case, transmission from local system to the EC2 instance must be secured. Client-side encryption allows the application to control the encryption key management. But there are also tooling options for managing the keys with client-side encryption. Cloudberry offers free options to browse S3 objects and manage keys for S3 encryption. SafeNet Protect app is another product that provides interface for key management. In S3 security architecture, each object is encrypted and decrypted by a unique object encryption key. The object encryption key is randomly generated. Each object encryption key is in turn encrypted and decrypted using master key. There are two options to manage the master keys. The first option is to use Amazon KMS to manage the master keys. In this case, the client will pass the customer master key ID to the KMS. Using the master key ID, KMS will generate, encrypt, decrypt, and manage the object keys. The second option is for the client to completely control the generation and maintenance of the keys. In the second case, the master key is called client-side master key. In this case, the keys completely reside locally. When the client-side encryption is used with Amazon Key Management Service, the client uses customer master key, but the master key is managed by KMS. The process of encrypting the S3 object using customer master key is as follows. The client makes a request to the KMS using customer master key ID for the object encryption key. KMS generates a one-time random data encryption key using the customer master key. The object encryption key is unique for each S3 object. It returns the plain text and the ciphertext versions of the data encryption key to the client. The client will encrypt the object using the plain text object encryption key. Client will upload both encrypted object and the ciphertext of the encryption key as the object metadata. The process of decrypting the object using customer master key is as follows. The client downloads the encrypted S3 object. It is in an encrypted form. The downloaded object also contains the ciphertext of the encryption key in its metadata. The client makes a request to the KMS to decrypt the encrypted object key by sending the ciphertext of the object encryption key and the customer master key. KMS returns the plaintext object encryption key. The client then decrypts the encrypted object using plaintext object encryption key. When the client-side encryption is used with the client-side master key, the client creates and manages client-side master keys. The process of encrypting the S3 object using the client-side master key is as follows. In order to encrypt the S3 object, the client generates a one-time random data encryption key. It encrypts the object encryption key using the client-side master key. The object encryption key is unique for the S3 object. Client will encrypt the object using the plain text object encryption key. Client uploads both the encrypted object and the ciphertext of the encryption key as the object metadata. The process of decrypting the S3 object using the client-side master key is as follows. The client downloads the encrypted S3 object. It is in an encrypted form. The downloaded object also contains the ciphertext of the encryption key in its metadata. Using the metadata, client determines the client-side master key. The client decrypts the data encryption key using the client-side master key. The client then decrypts the encrypted S3 object using the plain text object encryption key. The subsequent slides will demonstrate with examples the two options of the client-side encryption. The option of using customer master key with the Amazon key management service and the client-side encryption using client-side master key. The encryption algorithms used when using client-side master key is typically AES for symmetric encryption. The asymmetric encryption typically uses RSA. The demonstration examples are written in Java to show how the objects are encrypted using the methods described before. So, we first need to install Java 8 and AWS Java SDK. One of the methods we demonstrate is the client-side encryption using customer master key. So, we will also need to create a customer master key using Amazon Identity and Access Management Service. We can use either the console interface or the command line interface to create the customer master key. The console URL and the AWS command are shown in the slides. The KMS is an Amazon resource and thus has an Amazon resource name. It contains the customer master key ID which we record and use it in our program. 5 programs were written for the demonstration of the client-side encryption. Encrypt.java is the main driver program. It calls the necessary operations to create the plain text or the encrypted objects. It will also download, decrypt, and display the object contents. Encrypt.java uses classes from other programs to demonstrate various methods of encryption. S3.java is the wrapper program for general S3 object creation and retrieval. The other 3 classes contain methods that create, retrieve, encrypt, and decrypt the S3 objects. Each of those 3 methods perform encryption and decryption based on each of the 3 client-side encryption methods. I also wrote a bash script to drive the process of compiling and executing these classes. The operations supported by the demonstration are passed as a series of arguments to the script. The script then compiles and executes the classes to perform these operations. These test cases demonstrate various client-side encryption methods. It involves creating an S3 bucket. A plain text object is created with the content "Hello Cloud Computing World." The object is encrypted and decrypted using 3 client-side encryption methods: customer master key, client-side symmetric key, and client-side asymmetric key. The various operations supported by demonstration are the creation, clearing, and deletion of the S3 bucket. The operations also involve creation, retrieval, encryption, decryption, and the display of the S3 bucket. In the process of performing various operations, the program generates 3 keys. One is used for symmetric encryption. The other 2 are the public and private components of the key pair. The key pair is used for asymmetric encryption. Typically, the installations that use the client-side encryption using any of the 3 methods is responsible for establishing an infrastructure to maintain these keys. The customer master key based encryption, on the other hand, uses the Amazon KMS web service that does not necessitate this key maintenance on the client side. The first option is to create the bucket. This bucket will contain 4 objects: plain text and the object encrypted with 3 methods. After creating the bucket, downloads the object and display its contents. Notice the contents of the object is "Hello Cloud Computing World." The first object is encrypted using customer master key. Then it is downloaded the object and display its contents. The content of the object in the encrypted form is not readable. The non-printable characters are replaced with asterisk in the slide. The object is decrypted upon downloading it. The third object is encrypted using client-side symmetric key. The program generates and uses a symmetric AES key. It is stored in a file symmetric key. The fourth object is encrypted using client-side asymmetric key. The program generates and uses public and private key pair. They are stored in 2 files: public key and private key. The contents of the 3 objects in encrypted form are not readable. The non-printable characters are replaced with asterisk in these slides. The objects are decrypted upon downloading it. The last 2 actions will clear and delete the S3 bucket. The above steps of running the program generates and uses symmetric and a pair of public and private keys. The keys are stored in the three files: symmetric key, public key, and private key, respectively. They are stored in the files in the base64 encoded form. The contents of the file are shown here. These files can be read directly with AWS SDK or any other tool such as OpenSSL. I conclude my presentation with these points. Client-side encryption of S3 objects is an important component of S3 security architecture and provide an additional layer of protection to the contents of S3 objects by encrypting them both at rest and in transit. It offers the client the flexibility of the method of encryption and the key management. The client has the responsibility of managing the keys. These are the references used in my project. Some of these refer to the third-party options for the key management infrastructure and the Amazon Web Service and the documentation resources. My sincere thanks go to Professor Zoran Georgievich, the teaching staff, and my fellow students of the Harvard University Extension School Cloud Computing class for giving me an opportunity to learn about this technology. Thank you.